Hi, I'm Reshma, and I have Cody Hall here with me from the Unity AI team today. We're extremely excited. We're here today to talk about scheduling agents for healthcare operations with our friends at Unity. Cody Hall is the CTO at Unity AI and will be giving a lot of the presentation today. We're going to walk through a brief intro to Unity and then what problems it solves, what is very special about the Unity AI implementation, and a brief demo, and then open up for Q&A. That's what we expect to happen. But before we jump into it, I am Reshma, co-founder and CEO of Medplum. And one of the reasons we invented Medplum is that healthcare developers face what we call the terrible choice. If they want to build a cool app, they have to invest a lot to build from scratch. Or if you buy off the shelf software, you fight with it. So that's the choices that folks have if they are healthcare developers. We hope at Medplum to provide a third path, and our friends at Unity are really showing the way here. If you have a lot of pre-built primitives that are really great, then you can have a really much better experience when building your app. And Medplum and devs together work together to build exceptional healthcare products. Here's a system diagram that shows how Medplum works, and Cody will go in depth in his implementation, but we have a Fire REST API with a sophisticated identity management and policy module, as well as event-driven. And customers are building apps on top or interacting via the API and using our product framework to build powerful automations. So this is a suite upon which developers build and have a really seamless experience to build these custom apps. And we are delighted to work with many really great developers. The team at Unity AI is no exception. And I'm going to intro Cody Hall here. He's a CTO and co-founder of Unity AI. And he's responsible for the technical strategy, architecture, cloud engineering, platform ops, and security and compliance. And in a previous life was senior director of data science at HCA. So HCA is a hospital system that is renowned for their operational excellence and has a lot of sophisticated practice techniques. Cody has a very rich background in product development. He was led technical product development for a system called Spot, which is a sepsis prevention tool under the direction of HCA Chief Data Scientist Edmund Jackson, who's also here on this call. And there's a kind of monitoring and alerting system for sepsis. I won't talk too much about the clinical, as that is not my background at all, but it is a very cool system and renowned by those who used it. And we're all looking to collaborate. He's co-hosted seminars with Dr. Jeffrey Guy and a lot of physiology leaders, as well as development of advanced protocols and ventilator management, those type of very sophisticated medical systems. So thank you, Cody, for joining us today. And I am going to hand this over to you.
Excellent. Thank you so much, Reshma. Hello, everybody. I'm Cody Hall, here representing my team at Unity AI today. Let me pull up some slides and get this kicked off. Thank you for the introduction, Reshma. I wanted to talk with everybody today about what Unity AI is up to, how we approach solving problems in the healthcare space, and how that really builds on what a lot of us have in a shared career working on complex systems in healthcare with data. It's not an individual sport at all. I want to introduce my team here. Many of us started at HCA. We built a data science shop from scratch. We went down these paths of really deep clinical understanding. The work we did with sepsis was to say, how do we detect things early and then activate groups within the hospital to go do something about it? And one of the best bits of feedback we got out of that system, we're monitoring 40,000 people at a time across 180 hospitals. But the piece of feedback that we got was from a sepsis coordinator. Said, I don't have to spend my time in the morning collecting data. I can get right to work. I know what's happening. Spot has my back and makes me a better nurse. That's the type of thing we look for when making changes in healthcare. The impacts to patients, the impacts to the people who care for those patients. And that's all of us. Founder of HCA, the most successful startup out of Nashville, said, take care of the patient first and the rest will follow. And that's the core of everything, including down to the data models we use to represent these systems. What we're here to solve, we're doing all this really data intensive clinical patient deterioration monitoring. That was the easy part, aside from getting the data. But the communication and how people orchestrate around that was really challenging. So building apps was one way to do it, but then you have to sit someone down in front of a monitor and watch it. The communication protocols are limited in the hospital. Phone calls, some of it's text. We got into shared channels and shared communication through chat, like Slack. We use different tools, but still, there's a bandwidth limitation there. So we think high quality communication and coordination ensures access to critical services. And often there's little time for communication. So that's practically out of reach until recent advancements in AI and why we went down this path. The overall goal was the coordination of scarce resources. This is people, chair time, fixed asset time, and getting all of those things together, the temporal synchronization, the dependency synchronization, those are hard operational research problems or operations research problems. But we think we can take some bites out of that with some of the things that we're building. We're focused on scheduling. The algorithms are out there, the clinical calculators, ArtsNet, SOFA, SIRS, you name it. They all exist. They've all been very well tested and they're in the literature. But getting people to coordinate around that is hard. So I found this interesting quote. Dr. Simon, Nobel Prize in Econ and a Turing Award recipient, said, decision makers can satisfy, I love this word, either by finding optimum solutions for a simplified world or finding satisfactory solutions for a more realistic world. And when I think about what FHIR and Medplum and this community working in health tech represent, we're getting better and better at capturing what the realistic world looks like in data. And so the more we do that, the better solutions we can come up with. But humans today are really good in the scheduling space at finding the meta heuristics, finding the pattern recognition, doing this all. And it takes a long time for those folks to become experts in what they do. And they're still limited in some ways. Again, back to the communication constraint we see, it's driven by human to human interactions. And if you think of these as negotiations, we're asking humans to constantly take in new information, go check and re-coordinate certain things. And so we asked these human schedulers to make 10 confirmation calls. If someone doesn't confirm in that confirmation call, they're not going and tracking down who else can I rebook at that time. They're going through the rest of the list of confirmation calls. We're often not constrained by the equipment, but the efficiency in which we use that. So voice agents represent a solution to this communications constraint in that they're scalable. They can reach more people. They can react instantly to changes and avoid this sort of problem of under communication, suboptimal schedules, turns into unused capacity and worse access for people.
This is what there's a complex negotiation that's really going on between all the stakeholders all of whom are experiencing scarcity of different kinds, and they need to be reconciled in a very event-driven real-time way to get stuff done. So
better schedules unlock better care, and optimizing around these negotiations that need to happen and creating the capacity for that is a huge way to improve the way we get people access to healthcare. The other big one is data standardization, and Reshma and her team are doing an incredible job of building the foundation to be able to build better systems on that. Goes back to the FHIR standard and the people who developed that, and then comes down to implementation in the shop. I got a chance to meet everybody at their conference this year. I was just super impressed. I got to go to their office and see everyone just really dedicated and focused to creating a great implementation of the FHIR spec, including the data, the API. We'll get to more of what that means later. But it's all some of the interoperability and the federation where it's not just one system anymore. FHIR, by its nature, is really designed to be interoperable. And what that means, we're just so not used to thinking that way in healthcare. Yeah. What that really means is yet to be seen. So I want to show you something in a little bit that kind of drives to that point.
Resonates here. We've said this a lot of times. Standardization is really important, not only for us humans, but the agents really benefit from it too, and they can help.
I love the FHIR website. I spent a lot of time there. And at the bottom, layer 4 is reasoning. And so everything else is administrative and observations and these things. At the bottom, where we can get to that part where it's reasoning over all of these things and doing that in interesting ways. So that's the second part of the two bottlenecks we're working with.
Yeah.
This, again, just to go back, this is a big problem. Clinicians do what they do best. They know how to solve treatment delivery, but it's really hard to get the right people in the right place. And so any missed slot in a schedule or inefficient match represents to business, lost revenue and staff underutilization, to patients, longer wait times, delayed diagnosis and treatment. And then overall, if you don't have the people who run this, if you don't support them with great tools, there's higher chance for burnout. So that's what we're trying to solve here. These agents act as always available negotiators. They reach more people. They can react to changes. They continuously fill gaps in the schedule, and they connect people's preferences and eligibility together to make that all happen.
Very cool.
We think those two things come together to unlock some really interesting capabilities. I want to share a few stories around patients, operators, and builders of these systems that I think will resonate with this crowd. Taking care of the patient first is really core. We're all patients. We're all helping other people take care of their loved ones, whether they're children or parents. And FHIR lets us match the reality of care with backed by data. One of my favorite resources is that related person. There is the patient at the core of all this in the FHIR data model, but then there is a specific resource to talk about who are all the related people to that person. And these can be a parent. They can have attributes like, this is the appointment contact for this patient. This is the related person who has the attribute of, we'll transport them somewhere. Taking care of each other, it's a team sport. Not everyone can drive themselves to a thing. I am taking care of my dad. If people call him about his appointment, I don't know what you're going to get. They need to call me. And I think about this as I'm interacting with him and taking him to different appointments and coordinating with my sister to take him to appointments. I think about the data model behind it and how nice it would be to update everybody and say, look, the related person in charge of appointment scheduling for this patient is Cody. Call Cody, not him.
This
And
is a really subtle point, but
Yeah.
super important. We see this all the time at Medplum too. We have a lot of pediatrics and elder care on the platform, noting down who's people's related person. And then we also support special kind of authentication. So you can authenticate with consent the records or status of those related persons to help manage their caregiver access. I think it's awesome that you all have built a agent that really keeps this in mind. Can person come with me to my appointment? That's an important part too.
It's a big deal. And FHIR is very interesting and nuanced in that the related person in charge of care may be a self-reference to the patient.
Yeah.
Once you start to understand and adopt the FHIR, what did the creators of FHIR mean by this? You realize that you don't have to have logical branch that says, if patient doesn't have this, do this. You can just say, find the related person of type appointment contact. If that's the patient, great. If it's somebody else, wonderful. It's all right there. So you don't have to do a lot of customization if you get the data right. And that's why we love building in this space and why it unlocks our team to be able to take on and lean into the complex cases, the cases where I have this picture here below representing a family. A parent is making, let me go back. A parent is making a dental cleaning appointment for 2 kids at a time. And do we simply represent that as 2 tasks, or do we represent that as 2 appointments with 2 patients and a related person for each appointment that we want to go confirm? We'll talk about a confirmation workflow. Do we look up the related person of type appointment contact and then look up the person resource and map back and say, does this person we're about to contact have anyone else that is also having an appointment that day? That's what the human schedulers are doing at the front desk. They'll look at the next day and say, oh, look, the Jed family's coming in tomorrow. I know who to call. But when we're designing systems to do this, we have to be pretty thoughtful, get the data correct, and then think through, how many times should I really be contacting Mr. Judd if 2 of his kids are coming in tomorrow? Probably only once. Solving those nuances and helping.
How does Unity work through all of these complexities, assuming they're stored properly in the data model?
Yeah, the fortunate thing is we get a lot of great examples from our customers. They tell us what they need, and so we're intently listening to that and then modeling it. I think one of the nice technical thing we have in using Medplum is when we get that data organized and correctly applied in the schema, we have things like the GraphQL layer where we can ask these questions and be really expressive and say, return to me the list of appointments that I could possibly contact this person about. And so that's where we get some really nice expressiveness out of using the tools that Medplum brings forward. I'll go into another example where increased communication helps with patient access. We make a confirmation call. A patient can't make it. So the system understands who else could possibly take this appointment. We don't want that slot to go unused. So can we generate a prioritized list of people to reach out to and see, based on patients B through Z on that list, who can we call on? So that person who may be waiting to have a scan to go down their diagnosis path and begin treatment may have had to wait 2 weeks. Now they can get in tomorrow or the next day because something opened up. Human schedulers just don't have time to do all of that. And then if they do bump that patient B up, can they go call and make sure the next slot that just opened up is available? At some point, we have to choose a stopping point, but the idea is that with these scalable communications, we can start to do the next step and actively scale that so that accessing is increased for everybody there. That's also good for operations because Dr. Perlin said many times, good quality is good business. If you can increase the availability of treatment to people, it's also good for business. In a radiology example, they're doing procedures, they're running scans, they have fixed assets that are maintained and open, staffed appropriately. And then the possible set of people who may need that access get referrals, get scheduled, confirmed to show up. They're prepped so that when they show up, they can actually do the procedure necessary. And the whole chain of referrals to scheduled to prepared lets the clinics increase their volume and increase the density of their schedules and the utilization of their fixed equipment. All this not only helps the patients, but absolutely helps the customers, the buyers in this case of Unity software who are trying to drive their operations in their clinics. We think that leaning into the complexity of scheduling is the right way to make a big impact in healthcare. There are certain infusion protocols that are very complex, and they go from patient intake forms. What's your latest weight? We need that to get the correct dosing. We need all the benefits and prior auths to line up. All of your lab results need to come back. Before your visit, we need to verify that you've stopped taking certain meds and you're on MPO or whatever the other requirements are. And then treatment can happen. But all of that stuff before that is managed by humans. And there's a sense of, can we get that to a point where these agents are acting as coordinators? The humans are acting as exceptions. So they're not doing the logistics. They're not doing the lookup. They're not doing the data collection. That's all for agents. This is Rahul's pyramid of tasks and working to the highest level of capabilities there.
This is a complex workflow with requirements for medication to be available, for the patient to be available, the clinician, and then there's prerequisites that the patient has to do, and the agent, assuming everything is stored in a file with the correct structure, can reason through reliably. Wow.
Exactly right. And because there's formal ways for us to describe each of these points in FHIR, an expensive medication is dispensed. There's a med dispense resource. We know that's on site at that location. It has a shelf life. So if for whatever reason the prerequisite flow here fails, do we know who else is eligible for that medication, and are they prepped? Care time, expensive medications not going to waste, are reduced, and that is beneficial to these groups. But it all boils down to, like you just said, having the ability to represent that with fidelity in FHIR schema. And so it's very important if you're building these systems to to be there with your schema. We had the choice early on, should we adopt Fire, should we not? We're so thankful we did, because it just unlocks so much ability to represent the world. Again, back to the operations research quote, we don't have to simplify the world so much, because the reality is there's a whole lot of detailed things going on. It's also great for builders like us, many of you on the call. We're building in healthcare, we need good tools. Thankfully, Medplum brings that to us. We started with Magic, Mumps, M. This was designed and spec before Unix, and it stood the test of time. Everything still runs on this in its downstream iterations. And that was great, because in a hierarchical database, you have your primary system, and all these modules can sit on top of it. If you need something that's not built into that primary system, you have a way to get information in and out. It's expensive, it's painful. Organizationally, people are not good at this. They'll think we need this solution with the minimum set of HL7 interfaces we can buy, test, deploy, and then you don't have something that's robust for general use. So this way of going about building healthcare platforms, extending healthcare platforms, is fraught. I think it's why we have so many solutions out there that really don't feel like they go together. You end up having to look at 10 different screens. Anyone who's built in this space understands this. But if you replace the foundation layer with Medplum, and you start to talk about Fire resources instead of paths to lookups in hierarchical databases, you end up collapsing that into a modern architecture. You have Medplum, you have Fire resources, you have applications that sit on top of that. And there's still this question of what's the way we incorporate or add on to that outside of primary systems. And there's two ways. A modern application client can reach into multiple backends, make different requests. Medplum and the Fire standard offer us really nice ways to set up things, subscriptions, bidirectionally, something from one system can talk to another. Those resources are kept in sync, and you can define triggers and events. This is a very nice way to go about things, and we'll demo something that kind of illustrates this point here in a second. But getting to the point where we can have systems that are built on foundations, both platform and data, allows us to start building. I think we'll see EHRs built in this way in the future. Not everyone out there building an EHR wants to go as deep on scheduling, how to represent it, how to build agents, and reasoning over it. It's very specialized, and we're putting a ton of energy into it. And so we'd like for anyone else building their EHRs in these verticals to be able to take advantage of that. So I think what we're going to start seeing is people building core systems that multiple domain verticals can tap into. And so what's really cool about this is the Medplum and the Fire standard really help us make this possible, where we can have one or more really good scheduling solutions out there that someone working on a behavioral health app or dentistry or infusion, radiology, they're worried about very specific things that those clinicians need to record and represent and reason about. But scheduling has a shared set of concerns around what that vertical is doing, but also just the base operations research and communication requirements there that go into it. So I'm really excited to see if this is the future of EHRs, and if Medplum represents a distributed EHR in that way. We have standard APIs, we have standard data. The network is coming or here, and that allows the formal interoperability. There's also people partnering and doing this on a tight integration level. These horizontal segments of scheduling, insurance, rev cycle, we see examples with Steady. Oftentimes when we're making a confirmation call, someone will say, hey, can you also check their insurance? And we're like, we would love to. We would love to reach out to Steady and do that instead of trying to implement that ourselves too.
Composability is so key here. It just needs to, this is the superpower of open source, but yeah.
Exactly. Medplum's doing all this in the open. There's a great community around it. We're excited to be a part of that. And having spent so many years with Meditech 5, 6, and other systems, it's just really refreshing to be able to think about EHRs in this way, not having to do as far as wrangling data, but get to be expressive and start to work at a sort of a higher level there. I'm really curious if this takes off. I'm excited about it. Anyone who's building an EHR, you might think of a schedule at the top here. This is a representation of what happens at a point in time during the week. But really, a schedule, going back to some of those complex examples, looks like this. It's a huge dependency graph, and it's dynamic, and it's changing all the time. And we have to have a way to describe that in data and then reason over that with things like agents. What we're doing at Unity is we're starting to go down this path of being a part of that ecosystem. One of the things that we thought a lot about is using Fire resources both as external interfaces that are static and internal interfaces that represent our workflows. In a very simple example, a confirmation request is submitted as a bundle. It includes more than just a communication request. It includes an appointment, a patient reference, that kind of stuff. But another system can send that bundle in that format, and then we can take that and do work on that bundle. So in this case, we'll generate a task. It starts off active. We initiate a workflow. We're using a durable workflow execution engine to handle workflows campaigns. We version those so that when we're trying to figure out what is the best way to handle confirmations, we collect all that data and we have the ability to score it and evaluate it, make sure that we're designing the most effective campaigns across multiple modalities, voice, text. And we can update our internal references when we get a confirmation, which can update our external references. The really awesome thing about Medplum and what they've done with access policies is that we can basically build a container for this external resource so that the person integrating with us can generate one, get it anytime they need. They can even subscribe to it. And so if they're using Fire to hire these agents to go do this, they have their representation. They can always check it or change it. If they got a confirmation a different way, someone called the front desk of a facility, they can update it for us. We'll stop work on our end. And this thing can keep the communication requests constantly up to date. So this describes the flow of that. On a slightly deeper technical level, just to run through this, we also talk about the creation of appointments. Use the first order assets that are available to you. So we prefer not to model things as call somebody, but here is an appointment, and these agents know what to do when an appointment exists. And so we use Medplum Server. We have an app layer that subscribes to these events. It will kick off workflows that have side effects and then report back using Fire as a main point of integration, and the ability to signal, stop, start workflows. So I'll show a quick demo of that just now. This is an example of that someone can send us and hire our confirmation agents. Very simple workflow, but you can see where this goes. So we model the patient, we model organization, the appointment, we model consent. Consent's really tricky when you're doing a lot of referrals and engagements and outreach. It's important to have consent to contact people, and people can send that and share that with us directly, that we stay on the right side of some regulations around that. We can also get the communication requests, which ties together. This is based on an appointment. Reference is a subject. The requester is the organization. Please contact the patient to confirm appointment. These generally came to us. Either we would reach out to an EHR or we would get a CSV file of all this stuff. By the time you create an ingress path for all of that and ETL it in, and then create people want the information back. What was the communication? What was the transcript? That's all done in interesting ways. We want to be able to standardize that. And even if we have to offer services to folks to help them get through that and build it with them, we'll still use these requests internally. I'm going to submit this bundle. This is hitting our dev API. And then it's going to call me because it wants to help me confirm my appointment. Second here. We can listen to it. All right. This is generating a phone call. Put you guys on speakerphone. Hello.
Calling to confirm your appointment. May I speak with Cody?
This is Cody.
Thank you, Cody. To confirm your appointment, I'll need to verify your identity. Could you please confirm your last name for me?
Hall.
Thank you, Cody. Now, could you please confirm your date of birth?
January 1st, 1970.
Thank you for verifying your information, Cody. I'm calling to confirm your appointment scheduled for today, Thursday, October 30th at 4:30 p.m. Central Time. Does that time still work for you?
Yes.
Your appointment has been successfully confirmed. let me share some important preparation tips for the session. For today's appointment, it's helpful to think about the main issues you'd like to focus on, any goals you have for therapy, and any mental health history that might be relevant. If you're taking any medications or have any important notes from previous providers, feel free to bring those to the session. Is there anything else I can assist you with, or would you like any information repeated?
No, thank you so much. I appreciate it. Take care. So that was walk you through what just happened there. There's some interesting bits I want to call out. This bundle here created, at the end of the day, a communication request, which is represented here. It's based on an appointment. It has a subject. All these references are active. So it started off in that. Our app created a task based off of that. So we received a Fire subscription. Hey, there's a new confirmation request out there. We generate a task. We have additional inputs and values and things that we associate with that. We maintain certain references. If needed, the agent can keep looking those up. You notice that we did a validation step. And so this is the debug information effectively of what happened, what were we looking for, what did we get, did it work? And so all of the details about what are happening in these communications can be tracked with high fidelity so that we can give that back to the customers if they ask for it. We can use that to increase our quality. And then finally, we'd love to come to the appointment. This communication request representing the appointment confirmation is complete. And that's the whole workflow there. You saw the agent do a very specific but simple thing. So today, live with customers, we have referral workflows. We have confirmations, which is what you just heard. If a patient doesn't confirm and says, no, that won't work for me, we can offer them the ability to reschedule if we have the schedule information from them. We also have the ability to turn on a front desk agent, which will handle incoming calls, understand what people are looking for. Maybe it's to confirm, maybe they need to reschedule. The person calling in can initiate that. And so we're doing on the order of about 10,000 calls a day throughout these systems, all built on Medplum. The active development is what you just saw. So the Fire API, working on implementation guides. I've been reading Fire IQ guy, figuring out, making sure that we're doing the Fire part well and adhering to the spec, but also working with customers to beta test this. So we're opening that up soon. If you're interested, we'd love to catch your intent. If you're building a Fire or even a regular base EMR, practice management system, EHR, we would love to talk to you about how you might integrate with that API and what you can do with it. Staff scheduling is a big piece. We talked about the demand side, making sure people show up prepped and ready to go. But also we need the same thing for who are the caretakers, the people who are providing the care. We think those are both part of the same equation. Some really interesting stuff you can do if you start to see really high demand. Maybe we can fill these slots, give people some overtime, pay an extra hour, get 3 more cases done. How can you start to do that, negotiate that with these agents in real time and throughout the week? So you're not planning months ahead. You can say, would anyone like to staff this equipment on this day? We have 3 cases. Go get all that negotiated, get it done, and increase the availability and access to that care. We talked about multi-appointment or series scheduling. That's when, you have your first visit and then follow-ups regularly. And then densify, that's a shorthand for someone canceled, who are we calling next to fill that block? And we're just getting started here. We've got some great customers, great partners helping us think through the use cases. We're working across multiple different verticals, and we're building on some great tech. So we want everyone to build with us and see what we can do together. So thank you. Check out unityi.co beta if you're interested in that Fire API. We'll probably publish some blog posts and things coming up about that, but that will be the first group to know if you sign up. And then we're hiring, looking for great engineers, people who are into health tech and want to go down this path with us. So
Super exciting. Let's open for some quick Q&A in this past 10 minutes. We live in cool times, Cody. This is just exciting. I'm also chatting in the next webinars as well. Question and answer from the group here.
I have a question.
Yeah. Introduce yourself.
Thank you. Hi, Cody. I'm Borna. I'm the technical product manager at Impalo. We are a virtual cardiology clinic. And as a technical product manager, half of my role is developing the product, but the other half is patient coordination. I'm very excited about what you're building. One of my biggest pain points is referrals. And I noticed you mentioned referrals is not something that is live currently. How's that different than the demo you showed, or is it any different, or is it like the same workflow?
Great question, and thank you. Nice to meet you. The components of a call structure or an outreach or an engagement structure have a lot of overlap. And so we model referrals as a service request in Fire, and we would generate off of that the communication request and subsequent tasks and workflows. So we just start from a different entry point because that sort of meets the reality of what that resource was designed for and how we would use it. But the technical implementation, there's tons of overlap. Same tool calls for the voice agents, a lot of the same data structures underneath. And we're constantly evaluating, are we using the Fire resources correctly? Are we implementing with as much of the same abstractions? Our agents started off very monolithic, and now we're getting to the point where the agents are more modular. There's a verification step. There's a confirmation step, or in this case, maybe, yeah, I'd love to be scheduled. Go ahead and schedule them or escalate them to a human who can handle that. That's an overview of the referrals as opposed to what we saw today.
Thank you.
You're welcome. Thank you for the question.
I have a question if I can jump in.
Introduce yourself.
Hi, Reshma. Hi, Cody. Steve Yaskin, CEO of Be Human. We're actually using Medplum as our development environment. We built an entire platform basically on top of Medplum. A quick question. We spent a lot of time building bots, and we've utilized a fair amount of bots from Medplum out of the box, but then we've ended up building a few custom bots. Have you had any success in building custom bots, and what can be done optimizing that process?
Thank you, Steve. And Reshma, chime in anytime. Medplum gives us, Fire and Medplum has a great implementation of Fire, give us the underpinnings for systems of action. Subscriptions are really important. Bots, to me, in Medplum represent functions. And so if you have a bot listening to a subscription and event, something triggering it, now that bot or function can go do something with it. So it's the ability to call other systems or make a change within the Medplum data itself. We're constantly experimenting with bots. We have used subscriptions in the webhook sense, where our own services are consuming those, but it's very similar. So to me, just thinking of bots as functions and that we have those underpinnings for the system of action. So this change, what do we do about it, is what bots represent to me. Reshma, I think you have probably a lot more to comment on there. Okay.
Cody had this diagram here that he drew, and we really do believe that there's customization will be required to be successful as part of doing these implementations. There won't be a really canonical implementation of all these things. So bots are meant to be that composable abstraction. So we, of course, provide some out of the box for common workflows, but we know that infusion workflow is just not going to yield to something that's very cookie cutter. It is our hope that custom bots are really a very powerful avenue for those customizations, as well as a way to prevent a lot of commingling with your business logic, your data model, your identity and access control. So you can have a platformy feel with a great, robust implementation that's reusable.
Just an idea, everybody. What if Medplum create GitHub for bots sharing and efforts? Developers could share their own bots implementations. Having be the first one to jump in and contribute to ours. Get the GitHub going on that.
It's a really good thought. And we want to reduce the repetitiveness. They could either be a template for others or actual usage.
Bots are pretty universal things. And we ended up doing bots for everything. And some of them are pretty universal and extendable.
Others in the group wanted to chime in. A lot of us are programmers, so bots, functions really make sense to people. But how to communicate that to someone who has more of a clinical or functional background? That's a communication device that a community could help frame the message to different disciplines. More questions? We have a couple more minutes here. See some in the chat. Do you store all your data in Medplum Fire Data Store or have another data store that Fire doesn't fit in well? Good question. Cody, if you have a comment, enthusiasts, apologists, and I do see some folks, I don't want to put Carrie on the spot, but she's also very experienced modeling for fire. There is a lot of flexibility to it. It's maybe not obvious. Sometimes asking Claude and friends for help in doing your model is also useful. But Cody, if you had a comment here too.
I sure do. We're constantly tempted to go outside of fire. Oftentimes those discussions come back around to what if, and it's about access patterns. You want to be able to retrieve all this data together or query it with GraphQL or do something. It's important that you have it available in fire. We're now starting to get to the point where we're defining our agents and our prompts and everything else in fire. One of the things we do with another partner system is we need to be able to just store general config, and we're like, should we have a config server or should we use Medplum? So those types of questions come up all the time. I think Medplum, I'm curious what your thoughts are on this and your team's thoughts are on this. If people come up with a really good new fire resource, could we propose that and have it and contribute that back? But we'll see. The goal is to keep things in fire as much as possible, for sure. That's our guiding principle, but there's always exceptions that you come back around and solve later again in fire, and that's a fun process.
Totally. Some great comments in the, I think, yes, we do, I think, community driven with respect to extensions or like new resources that might serve purpose. I want to make sure we're judicious with people's time. Thank you everybody so much for joining our webinar today. We're going to send out a recording and some kind of materials related to this. And thank you, Cody, for preparing this wonderful presentation. We're really excited to be here in community with you all. And we will hope to see you at future events as well. Put some in the chat and welcome any signups and joiners. Channels are open. I'm Reshma at medplum.com in case you want to reach me. And we will thank you again for coming on out.
Thanks for having us, Reshma. Appreciate it so much. Thanks to Medplum team. Thanks everybody who joined.
Close this out.